Today we are going to read and highlight the first lesson in Unit 2, Shaping Earth's Surface. Make sure that you scroll into your CAMI document down to Lesson 1, which starts on page 4 and is called Earth's Landforms. The Grand Canyon. The Grand Canyon is one of the deepest and widest canyons in the world. It is so large that it can be seen from space. At its widest, it is 29 kilometers or 18 miles across. It is 446 kilometers long and more than 1.6 kilometers deep. So that's 1 mile deep and 277 miles long. The canyon holds clues to Earth's past going back 2 million years. Like detectives, scientists study the properties of the rocks that made up the Grand Canyon. These rocks tell a story about how they were formed and what the environment was like when they were formed. By studying the rocks, scientists have learned that Earth's surface is always changing. Properties of rocks. The Grand Canyon is made up of many different kinds of rock. Rocks make up the surface of Earth and other terrestrial objects, including planets and moons. They are kinds of matter made up of different mixtures of different minerals. Minerals are naturally occurring. This means that they are not made by humans. They would exist on Earth without people. Minerals are also inorganic. This is because they are not the product of something that was living or was once alive. Leaves and shells are organic because they came from something that was once alive. Minerals also have a definite chemical composition. This means that every mineral is made up of the same kind and number of atoms. Lastly, minerals have an orderly crystal structure. This means that their atoms are neatly organized to form a repeating pattern. When minerals are pressed together by heat and pressure, they combine to form different kinds of rock. A changing planet. The clues in Earth's rocks tell scientists that Earth is about 4.5 billion years old. The rocks also provide evidence for how the land has changed many times since then. Scientists believe the Grand Canyon formed 5.5 million years ago. Before that, nearly 2 billion years ago, mountains rose 10 kilometers or 6 miles above sea level where the Grand Canyon is today. This is as high as the Himalayas are. Over time, the mountains wore down. The land became flat. Oceans covered it, and then a major disturbance changed the land. This disturbance pushed up the entire seabed to form a plateau. A plateau is an area of land that is relatively flat and significantly higher than the surrounding area. Scientists can learn all about these changes from the layers of the Grand Canyon's rocks. They do this by analyzing the properties of the rock. They look at the size, the shape, and the arrangement of sedimentary particles. They also look at the rock's color and its hardness. These properties tell scientists about Earth's environment over time. For example, sediment may reveal ancient oceans, glaciers, and swamps that existed and disappeared over time. For example, some of the upper layers of the canyon are made up of rocks formed at the bottom of the ocean. The only way these rocks could end 14,484 kilometers or 9,000 feet up in the air was if the land that was once the seabed were suddenly pushed upward. Earth's structure. To understand how a seabed might end up 14,484 kilometers above ground, it is important to start with Earth's structure. Earth is divided into 4 layers. Scientists learn about the inside of Earth by studying rocks on the surface. The center of the Earth is a solid ball of metal, iron, and nickel. It is called the inner core. The core is 7,000 degrees Celsius. It is hotter than the surface of the sun. The outer core wraps around the inner core and is made of liquid iron and nickel. The mantle is located around the outer core. The mantle is Earth's thickest layer. Imagine an apple. The core of the apple is like Earth's core. The fleshy part you eat is like the mantle. Earth's mantle is an ocean of semi-solid rock called magma. Earth's skin is its crust. The solid crust is the coldest layer or coolest layer of the planet. It forms the continents and holds the oceans. Plate tectonics. Earth's crust is broken into drifting slabs of rock called tectonic plates. The plates cause Earth's surface to look like a jigsaw puzzle. Heat from Earth's core causes the liquid rock of Earth's mantle to rise and fall like ocean tides. As magma moves beneath the crust, it pushes the tectonic plates toward or away from each other. The places where Earth's tectonic plates meet are called fault lines. The different movements of the tectonic plates change the surface of the Earth. The movement of the plates is what caused the ancient seabed to lift high up in the air and create a plateau. When two tectonic plates collide, the force is so powerful that the land is uplifted and mountain ranges can form. When two plates move toward one another, perpendicular to the fault line, they form a convergent boundary. Most colliding plates create mountains. Scientists do not know why a plateau, not a mountain range, was created where the Grand Canyon is today. The colliding tectonic plates can also result in earthquakes and volcanoes. Earthquakes are vibrations caused by the movement of tectonic plates. Volcanoes are structures formed around a hole in Earth's crust that releases magma. When plates move, holes can open up in Earth's surface. This allows magma from the mantle to ooze into the crust and form volcanoes. Sometimes two plates move apart from one another, perpendicular to the fault line. These plates form a divergent boundary. This movement creates ocean trenches and valleys. It also can result in earthquakes and volcanoes. Transform boundaries are formed when two plates slide past each other in parallel, grinding along their sides as they go. This causes many earthquakes along the fault. Landform patterns. There is a cause and effect relationship between the movement of Earth's tectonic plates and the locations of mountain ranges, earthquakes, and volcanoes on Earth's surface. As a result of this cause and effect relationship, mountains and valleys, earthquakes, and volcanoes are common at fault lines. This results in patterns in their locations. For example, volcanoes and earthquakes often occur along the boundaries between continents and oceans. A continent is a main landmass around the planet that is made up of a tectonic plate. There are 7 continents: Africa, Europe, Asia, North America, South America, Antarctica, and Australia. Major mountain chains form inside continents or near their edges. Make sure that you put a star near this diagram, both diagrams here. The convergent, divergent, transform boundaries picture, as well as the different plates of Earth's surface. Once you're done, make sure you have everything highlighted and then move on.